In this video, we'll show you how to start adding behaviors and interactions to your game. First, we'll focus on movement. Before you begin, plan what you want to do. On your video companion worksheet, write down each breed and what type of movement you want them to follow, if any movement at all. Obviously, something like a tree doesn't have to move, but it could. Some examples of types of movement include being controlled by the keyboard, spinning, random movement, and following other objects. In our example game, the player is a toy train who goes around collecting treasure while avoiding the monster that is wandering around. We're going to make the toy train, which is the player's character, follow the keyboard controls. We also want the treasures to spin and bounce a little to look nicer, and the monster will wander around randomly. We might also decide to create some trees and grass for decoration, but they'll just stand still, so we'll ignore them for now. There are several useful skill cards for movement, like follow, avoid, jump, fly, teleport, and keyboard controls. We'll do the keyboard controls skill card to add keyboard controlled movement for the toy breed. It's pretty much the same pattern repeated over and over. If a certain key is being held down, do a certain movement or action. In this case, if the up arrow is held, go forward one step. The rest of the keys for backward, left, and right are programmed the same way. The other movements we want aren't on skill cards. That's spinning and bouncing and random movement. First, we'll add code to make the treasures spin and bounce. To make them spin, drag out a While Forever toggled block from the interface drawer onto the treasures page. Then, from the movement drawer, we'll choose a block to turn right, and we'll say by 20 degrees. To make it bounce, we'll use an up and down block, and just make it go up and down by 0.5 steps. If we did this, we wouldn't actually see any bouncing because the up and down happen right after each other, too fast to see. But if we go into the logic drawer and get a yield block, we can make the agent pause ever so slightly after going up and before coming down. But now it's not spinning on its way back down. I know, let's get another While Forever toggled block and drag the up and down blocks over to there. Now, it will always be spinning, because of this While Forever toggle block, while simultaneously moving up and down because of this one. Okay, one more thing to add, the monster's random movement. For this, we'll need another of the While Forever toggled blocks on the monster page. Then we'll add forward, left, and right. If we stopped here, the monster would just go straight forward because the left and right would cancel each other out. But we can get two random blocks from the math drawer to turn this into random movement. This way, the monster always turns some random amount to the left and a random amount to the right. So sometimes it'll be more to the right and sometimes more to the left, depending on what the random numbers end up being. You can create additional traits for breeds besides the default traits of color, size, location, and such. Do you want to add additional traits such as health, energy, age, or anything like that? Once you decide which traits to add, fill out the table in your worksheet. In our case, we want to give our player, which is the toys, an energy trait. To do that, we go to Edit Breeds, and then we choose for the toy breed, we choose Edit Traits, and then we add a trait. And we're going to call it Energy. Now we can go over to our setup code in the world page, and we need to give this trait an initial value. So we're going to take out the set my block, and we're going to choose set my energy to 10. So that's going to be the starting energy for the toy. Now we also want to make our toy lose energy when it moves. So to do that, we're going to go back to the toy page and to where we have our keyboard controls. And we're going to update the value of this trait in the movement. So we're going to set our energy to be what our old energy was, minus 0.25. And we'll do that after both the forward block and also the backward block, because either way you're moving. We also want the player to gain energy when it picks up a treasure, but we're going to do that in the next section because it involves collisions with a treasure agent. How do the various characters and objects in your game interact with one another? Look back at your game sketch handout from yesterday, review your responses to questions 9 and 10, and fill out the table in your handout to account for all of the interactions that you listed on your game sketch. In our example, when the toy and the treasure collide, we want the toy to increase its energy by 2, and we want the treasure to disappear. The way we do this is we can go to the toy page and drag out a collision block that says, on collision with treasure. And any blocks that we put in here are things that the toy is going to do. So we can increase the energy by 2 by saying, set my energy to be the old energy plus 2. To make the treasure disappear, we have two options. We can either go over to the treasure page and put a collision block there that says on collision with toy, then delete. Or back on the toy page, we could have just added the block delete agent, and we could use the collide block, which basically means the other guy. So now the toy, after it increases its energy by 2, is just going to delete the treasure. Normally, when you want both of the breeds to do something, you do it in 2 separate collision blocks. But since just making something disappear is so common, we made it so you could do that in the collision block of just one of the breeds to handle both of them. Take a minute now to fill out your table. Check out the Keep Score or Track Rival Score skill cards for information on programming score into your game. In our example, we'll add code to the collision between toys and treasures, which is on the toy page, to give us 1 point for every treasure that we collect. Since there's already a score data box widget, all we need to do is set the score data box to be 1 plus whatever the score data box used to contain. We can get the blocks to set the data box in the interface drawer. So set score data to score data plus 1. There are several things that you might want to use widgets for in your game, for displaying some values or some messages or things like that. For now, we're just going to create a new data box widget to display the player's energy. To do that, we're going to follow the widgets skill card, which says go up to edit widgets, choose new widget, and then we're going to choose a data box and call it energy and choose OK. So now we've created our data box, but we need to set its initial value in setup to reflect the initial value that the toy has. So back on the world page, after we give the toy some initial energy, we're also going to set the energy data box to be 10 as well. Now we need to go over to the toys page and add a block in the while forever toggled stack to update the data box continuously to contain the current value of the player's energy, because the player is always gaining and losing energy over the course of the game. So we get another set data block, and we set the energy data to be the player's energy. Remember that a procedure is just a collection of steps or commands to do something. For our example, we want to move our player's keyboard controls into a procedure because this while forever toggled block is getting kind of crowded, and we still have more blocks to add to it for the end of the game. To create a procedure, we're going to go to the procedure drawer and drag out the procedure declaration block, and we'll call it keyboard controls, and move the blocks out of the while forever toggled block into the keyboard controls procedure block. If all we did was this, then the player would stop following the keyboard controls. We have to remember to take a call block and put that where we took the other blocks out. And so this basically means where we used to have all of the blocks in the stack itself, now we just have a little pointer that says, now go do all these other blocks, and then come back. Look back at questions 2, 11, and 12 on your game sketch handout. How does the game end? For example, your game may end after a certain length of time, after the player reaches a certain score, or after the player collects all objects of a specific breed. It's all up to you. Once the game ends, how does your player know that he or she has won or lost? Use the End Game Early and Widget skill cards if you're looking for how to do some of these things. For our example, we're going to make the game end when you run out of energy. We do this on the toy page because it's the toy's energy that determines if the game is over or not. For your game, though, you might want the world to be monitoring the clock or counting how many agents are left or something like that, in which case you would put this sort of code on the world page. Anyway, for our game, we'll use an if block and a less than or equal to block, then a trait block, to check if our energy is less than or equal to 0. If it is, we want to simply turn off the game and delete everyone to indicate that the game is over. To turn off the game, go to the interface drawer and choose the toggle block. Choose toggle forever off for everyone. That means that every agent in the game is going to stop running any code. Then to delete everyone, just get that block from the agents drawer. That's it. Now we have a fully functional game that goes from setup all the way through gameplay until the game is over. Now it's your turn. Use the skill cards or some of the things that we showed in this video to add behaviors and interactions to your game.